Equations, solving with variables on both sides. So here are the steps you want to write down to solving variables on both side equations involving multiple steps with variables on two sides. So step one, we want to use the distributive property to remove the parentheses. Step two, combine like terms. Step three, move the variables to one side using addition or subtraction. Step four, move the number of terms to the side that has no variables. And step five, solve for the variable usually by divide or multiply. So let's look at some examples here. Let's start with, let's say I have 7n plus 12 equals 2.5n minus 2. I want to look for distributive property. Well, there's no parentheses, so there's no distributive property. Then I want to check each side for combining like terms. 7n and 12 are not like terms. 2.5n and 2 are not like terms. So now I want to look towards moving the variables all to one side. So I generally start with the smallest one. I ask myself, what's smaller, 7n or 2.5n, and I subtract 2.5n from each side. Because it's a positive 2.5n, if I subtract 2.5n, that will get the n's to go away. So this will allow the n's to go away from the left side, just leaving negative 2. And then on the other side, I have 7n minus 2.5n is 4.5n. Now I have all the variables to one side. It's like solving a two-step equation. I can subtract 12 from each side. Then I have 4.5n equals negative 14. Undo multiplying by 4.5n with dividing both sides by 4.5. And a negative divided by a positive is a negative, and I get about negative 3.1. So I want to look for distributive property, combining like terms, getting the variable to one side, and isolating the variable. All right, so we have 3 times 2x minus 5 equals 4 times x plus 1. What would we do first? Distributive property. So I always draw my arrows for distributive property. 3 times 2x, 3 times negative 5, 4 times x, and 4 times 1. Well, 3 times 2x is 6x. 3 times negative 5 is negative 15. 4 times x is 4x. 4 times 1 is 4. Then I want to look at combining like terms. Are these like terms? Nope. Are these like terms? Nope. So no like terms to combine on each side. So now my next step would get all the variables to one side. Well, which ones even have a variable? Well, 6x has a variable on the left side. 4x has a variable on the right side. So what's smaller? Positive 4x is smaller than positive 6x. So I think I would just subtract 4x from the left side, subtract 4x on the right side, because on the right side, 4x minus 4x, those are additive inverses, will zero out and leave positive 4. Then on this side, 6x minus 4x will give 2x. So 2x minus 15 equals 4. Add 15 to each side, and divide by 2, I get 9.5 from my solution. So we're looking for distributive property, combining like terms, getting the variables to one side, and isolating the variable. All right, let's try one. This one has a bunch of steps in it, lots of distributive property. So we're going to start, we have a 3 to distribute. We have a negative 4. Remember, we're looking at the sign in front of the number. Negative 4 to distribute, and a 2 to distribute. So I'm going to do 3 times 2x is 6x. 3 times negative 4 is negative 12. Negative 4 times x, negative 4x. Negative 4 times negative 1 is positive 4. You don't want double signs. Make sure you're just using single signs, because this can get really confusing. You start having double signs in here. So 2 times x is 4x, and 2 times 3 is 6. Then looking to combine like terms. No like terms to combine on this side, but this side I do. I have 6x and negative 4x will combine to be 2x. And I have a subtract 12 and a plus 4. That will combine to be minus 8. 4x plus 6 I'm just going to bring down. So notice how we're not working along a line. We're bringing everything down each step. And notice how these equal signs kind of line up to look like a train track. And the train track kind of helps us see that we're doing the same thing to both sides. Really nice and neat to have your work all lined up. If your work looks all jumbled up, looks like an elephant in a dust storm, things are not going to come out well. So being nice, neat, and orderly and having a system like drawing a little train track in can be super helpful. So then we have to get the variables to one side. I have 2x on this side, 4x on this side. I like to work with the smaller, so I would subtract 2x from each side. Give me -8 equals 2x plus 6. Subtract 6 from each side and divide by 2. All right, let's look at this one. 10 minus x equals -x plus 7. No distributive property to worry about, no combined like terms to worry about. I do want to try to get all my variables to one side. And when I do, I add x to the left side, add x to the right side. And I have additive inverses on both sides. And these additive inverses zero out and leave me with 10 equals 7. Does 10 equal 7? No, it doesn't. If the variable drops out and you are left with a false statement like 10 equals 7, 5 equals 12, -2 equals 3, something that's false, then you have no solution, meaning no number will ever work. You can write the word no solution, or you can write empty set, the little 0 with a line through it, meaning no number will work, but don't write 0 because 0 would indicate that 0 works for x. 0 does not work for x, nothing works for x. So empty set or no solution. So let's say we have 3 times x plus 1 minus 5 and 3x minus 2. We distribute. Combine like terms. Then I want to get all the x's to one side. I subtract 3x from each side, and it drops out. X drops out. I have -2 equals -2. That is a true statement. A true statement is -2 always equals -2, which means all real numbers will work. And sometimes you see this referred to as infinitely many solutions. So you'll see 3 words, either all real numbers or infinitely many solutions, meaning everything will work for x. And we start to notice that back here where we see the same equation on both sides. I would still continue to see that you get a true statement at the end as the variables drop out. If you get a false statement, remember that's no solution. A true statement would mean all real numbers would work. All right. Beware, look out for this negative sign in front of parentheses. Beware of the invisible -1. So this negative sign needs to be treated like a -1 and distributed to get -1x minus 3. If you don't distribute it, it will mess up your entire problem. So make sure that you apply this -1 to the x and apply it to the 3. Otherwise, things go bad. All right, you guys try this one on your own, and then unpause the video to see how you did. All right, welcome back. There's no distributive property, no combined like terms. To get all the d's to one side, I would subtract 4d from each side. Then I get d equals 8. Oh, that was quick and easy, just one step on that one. All right, let's try one last one. Try this on your own, see how you do, and then come back and unpause the video and we'll check it. All right, we don't have distributive property, we don't have like terms. I want to get all my k's to one side, so I would start with subtracting k from each side. Now, it would still work if you subtract 4k from each side. You would just have different steps. I subtracted k from each side. And then on this side, k minus k leaves nothing over here, and that confuses a lot of people. But we have a symbol for nothing. We have 0. 0 would mean nothing. So k minus k would give 0 there. And 4k minus k is 3k. Add 9 to each side, divide by 3, and k equals 3. And that will do us for equations solving with variables on both sides. OUT spells